right, so first let's go ahead and introduce our panel. Jim, if you want to go first, and then Chris, give them a little bit of info about who you are and why you're an expert.
My name is Jim Vajda. I'm the Chief Wireless Officer here at 7Signal. I've been here 4 years, and always fun to participate in these webinars.
And I'm Chris Couch. I'm a Senior Sales Engineer with 7Signal. I've been here for just over a year now, which is fantastic. I don't have a fun picture this week, though. I forgot to submit one.
Darn.
Hanging off a plane or something along those lines. But I have added a couple acronyms to the back of my name in the last month. So I recently just added the CWSP and CWDP to that. So that's fun. And on to the next. Continue my journey of learning. So hopefully to get to Jim's level of an NE by the end of the year. So we'll see how that goes.
NE by the end of the year. There it is.
I'm calling it out. I'm making it official.
And
Recorded.
It's being recorded. Yep.
Yes.
Stuck to it now.
Yep. All right. So let's go ahead and get started. Jim has been so very gracious to take this and even read the question for me.
Yeah.
So let's get into it.
And I'll just summarize this one, and anybody who's in the webinars can read all the details. But Nick has a good question, interesting question. He says their corporate Wi-Fi is set up with just 3 SSIDs, one for .1x, one for PSK, and then an open SSID for guests. And he's been told by management to actually try to reduce that number of SSIDs even further, which I think is actually kind of curious. And he says, well, it's technically possible to do that with .1x and radius attribute value pairs, to do role-based access control. He says that would just create too much complexity, and I agree. And then he wants to know, are there new edge cases that where they might want to deploy more than one, and how does 6 gigahertz factor in? So first of all, I think you're in a really good spot, Nick, because a lot of enterprises have kind of made a mess of their SSID planning, and in some cases it's a years-long process of eliminating SSIDs and getting down to what I consider the gold standard, which is 3 SSIDs, one for each authentication mechanism that you would have to support, one for .1x like you've got, one for PSK, and an open one. To get fewer SSIDs than that, you're going to have to move your guests to .1x. That could get you to 2, but man, that is painful, and I wouldn't recommend it. Your guests are going to complain and moan and groan, and there are going to be devices that don't work, and the onboarding software and portals for it are really clunky and cumbersome, and it's just a pain train, unfortunately. Yeah. So I think you're at the ideal spot. And what can you tell management in response? I would say it's you can show data that the SSID overhead, or I'm sorry, the beacon overhead from just the 3 SSIDs you have is very low, and it's not causing a performance penalty. And perhaps even a reference. Maybe Chris, I don't know if CWDP, the recent version, has anything to say about SSID planning, but I'm sure there are some sources that can back up the current implementation that you have. You'll never be able to get rid of the PSK network either, right? You can.
No.
That's very clear. You say, hey, we have these clients.
I completely agree with you
on
the number of SSIDs, and when you get into the corporate argument, you really start shifting complexity from the wireless, not only into the wireless, but also to the security team and whoever's managing your NAC. So the complexity of managing all those policies and validating that everything's correct really becomes troublesome at times. So I completely agree with you on 3 SSIDs being just fine. You start getting above that, that's where we start running into some issues. But I think I think if you can convince them of that and show them a packet capture, the management will glaze over, but at least you'll have something to show them. And then the 6 gigahertz piece, I think, is going to be the more interesting conversation. Jim, what do you think about that?
Oh, sure. Yeah, and probably the first thing to start with
Nope, I think you
management
muted.
is say, hey, here are the enterprise clients we have to
Jim, you're
support.
muted.
Oh,
I can hear him.
you got me still? Looks like I'm
Yeah.
We
okay.
lost your
I can
audio.
hear you.
I would the simplest thing, is here are the enterprise
lost
clients we
everything.
support that don't support .1x. They have to use PSK. We can't get rid of it unless we stop supporting these clients. So that supports at least one of the SSIDs. The 6 gigahertz question is interesting because it brings up a couple considerations. One is the WPA3 problem we have in 6 gigahertz, where you may need to add a new SSID that's WPA3 only to support interband roaming for clients that are using 5 and 6 gigahertz. So you may need to add an SSID to do that. There's also, 6 gigahertz also is an opportunity to actually kind of overcome the beacon overhead problem, because you can use the multiple BSSID beacon element and support a lot of SSIDs with a single beacon. And there's some chat in the chat there from Martin talking about JJ Manila recommending multiple SSIDs for different use cases now. I think he's actually he's talking about this book, Wireless Security Architecture, which is a great intro to SSID and security planning, and might have some good references to help back up your position there. But I think you're right on. It's interesting that you've actually gotten to where a lot of enterprises are trying so hard to get to, and management's still not happy with it.
Very nice. Chris, are you all good over there?
Can you hear me?
Yes.
Yeah.
Can you
Okay.
hear me?
Yeah, I don't know. For some reason,
on.
my audio switched to my mic, and obviously that doesn't work. So
Oh, perfect. Okay. Well, I'm glad you got it all
You need a
sorted.
better dock, I think.
Yeah.
I need a
got
better
it.
dongle. Yeah.
It's all the dongle. Blame it on the dongle.
Yes.
All right. Perfect timing. So we're moving into question 2. So this is about some noise issues. So I have a problem with the noise that our wireless network is exposed to. How can I locate it, determine its strength, and avoid the noise? Is there a tool I can use to automatically change the frequency?
So yeah, this is kind of a little wide open, but we can talk about a few parts of this. So depending on what the noise is in the wireless, is it wireless noise? Is it, is it something else in the environment? Specific to what the question is about, but locating it, there's a couple different ways. I mean, you can use a spectrum analyzer like that's built in the Sapphire Eye. You can use an AirCheck G2, G3. They would be able to go around and find it using directional antennas and be able to figure out what is in the environment, and really try to figure out what's there. Is it something that can be removed? Is it something that needs to be remediated? Is it something that just can't be avoided? And that really comes into that changing the automatic frequency question of this is, there's a couple different ways to do this, whether you're using, event-driven RRM in the Cisco platform, or if you're using, some other system that has a DCA component that you're able to make those changes either globally or locally to that site. And then when the noise actually occurs, to really be able to hone in on it, I think is probably the best route. But normally I would say find it on site and figure out what it is. And if it's something that's consistent, plan around it is probably the easiest way, instead of letting your system kind of try to automagically do it. That way you're not, blowing all your channels away and having to reconverge all the time whenever it sees something come up. So Jim, what are your thoughts? Is that what you're thinking?
Yeah, I agree. I don't think there's a very good technology solution to this. I actually think it's more of a layer 8 problem. Use a spectrum analyzer, use 7-signal Sapphire Eye to discover where the noise is coming from and identify the system it's coming from. But then it should be escalated, and management needs to decide what the best use of the spectrum is. because it's going to be a problem for Wi-Fi, more than likely, if particularly if it's changing frequencies or if it's coming and going, if event-driven RRM is changing the channels of APs, in the middle of the day, that's, that helps, but it's also not great for the client experience. So escalate it and let management decide, who gets to use the spectrum, and accept the trade-offs in poor Wi-Fi performance if there are systems that are just you're gonna have to live with. So
yeah, absolutely. And that also comes into play when when it's IoT devices as well. And maybe somebody went rogue and bought an IoT device that works in Wi-Fi that you now have to deal with. So there's a couple different ways around it, but I think that's spot on.
Awesome.
So, and I'll say that not just the G-Check, the AirCheck G2 and G3, you've got the Ekahau Sidekick and Sidekick 2 that have the real-time frequency monitors.
Those
anything
are great.
Anything you can really use to get out there and see the frequency, or if you have Sapphire eyes, they have built-in spectrum analyzers as well.
Yep.
Don't forget Channelizer. There you
go.
Mm-hmm.
All right, moving to question number 3, submitted by Andrew. So question here with some context. We spent time designing and implementing a good 6 gigahertz system. Now we will have to be concerned about someone coming and using 6 gigahertz Bluetooth devices. Haven't we learned enough about the inefficient effects of CCA interference simply due to other Wi-Fi radios that we wouldn't want to add even more interferers with Bluetooth? Why, oh, why are the powers that be not pushing against this? Jim, why?
Well, there's a lot to this. I'll kind of start from the end and work my way backwards. But the ultimate power that be in the United States here is the FCC. They're the spectrum regulator, and they decide how the RF spectrum gets used, because the RF spectrum is public property, and so the government is in charge of regulating it. Most of the time, what the FCC does is very carefully centrally plans the use of the spectrum. They carve out pieces, bands, and say, okay, this is for cellular. T-Mobile bought the rights to this. T-Mobile, you can use this specific frequency band. You can use these types of modulations. You can use this. It's very tightly controlled and managed, and they do that for TV broadcast and for AM/FM radio, for police and fire. Everything is licensed and centrally managed and tightly controlled. And so one of the things that in the last few decades they've recognized is, the FCC doesn't know what's going to come next, or doesn't always have the best ideas about what to do with radio technology. And the strict, tight central regulation of spectrum can actually encumber innovation in some degree. So what they do in the bands that Wi-Fi uses, 2.45 gigahertz and 6 gigahertz, and also 60 gigahertz and some other stuff way up there, is they say, we're going to totally change our approach to these bands. These are unlicensed bands. And they even refer to them as the innovation bands sometimes, right? So this is more like, hey, listen, anybody can use this spectrum with just some very light regulation about, transmit power for and staying within the band and things like that. But that's it. And now that has unleashed Wi-Fi and Bluetooth and 802.15.4 and all these new technologies that have come out in the last few decades, because the people that are developing them and the companies that want to build for them can just go and do it. So it's good and bad. One of the costs of unlicensed spectrum is that you have to be open to interference from other sources, and that's what FCC says. So, And they also don't privilege any particular technology in the unlicensed bands. You know, we think about these bands being Wi-Fi bands, but Wi-Fi has no special claim to 2.4, 5 gigahertz and 6 gigahertz. And so, you know, the Bluetooth operating in 2.4 gigahertz, you know, or Bluetooth operating in 6 gigahertz from the Bluetooth perspective, they don't want Wi-Fi to interfere with Bluetooth. So it's you know, it all depends on your perspective, and we don't want to give Wi-Fi a special place that, you know, perhaps isn't hasn't earned there. But I would say that most of the time there's work between the Bluetooth SIG and Wi-Fi Alliance and the other major technology users in the bands to try to figure out ways to avoid interference with each other. The first version of Bluetooth was a kind of a disaster for Wi-Fi. I mean, they just stepped all over it. And then shortly thereafter, a while ago, now probably 15 years ago, Bluetooth added a feature called adaptive frequency hopping. So Bluetooth is a frequency hopping technology that changes channel very rapidly across the whole band. But with adaptive frequency hopping, it can detect OFDM transmissions from Wi-Fi and take those out of the channels that it's hopping across. And usually that's really good. We, you know, in my experience, I start to see Bluetooth really causing problems for Wi-Fi in big open areas with a lot of active Bluetooth transmitters. Like the two scenarios that pop out are big, like gyms where a lot of people are there with their headphones or AirPods actively streaming audio. And it's, you know, there are very few walls and the signal just carries forever. The other one is big carpeted office space, open floor plans. Everybody's using Bluetooth mice and keyboards and headsets, and they're actively using them, right? That's a key. They're all transmitting at the same time. That can really be a detriment to Wi-Fi.
You know, I'll add two more scenarios to that, Jim.
Yeah, go ahead.
This has been a few years back. So when I forget who the manufacturer was, but I was in a few warehouses that had Bluetooth linked printers and like hand scanners that were like finger scanners that were Bluetooth that went to a attached radio, also working with a pick to voice system. So combined all that together, it was completely terrible. And the second one was a healthcare system that decided to go on a health kick with their employees and gave everybody Bluetooth enabled pedometers. So every employee had Bluetooth enabled pedometers as they walked through the hospital.
Yeah, and healthcare workers are always on their feet too.
It was not a good time to look at that environment. So
yeah. Anders in the chat, call centers, absolutely. They make the mistake of buying 100 Bluetooth headsets for everybody and cause an issue. So I'm getting the hook here. I do want to just mention 6 gigahertz. I don't think it'll be a big problem because of adaptive frequency hopping and because there's so much spectrum. It won't be difficult. And the technical details of this haven't been released, so I don't know, but I suspect it won't be difficult for Bluetooth just not to be using any of the spectrum that the APs local to it are using. Again, there's so much spectrum, and all you really have to worry about is what are the APs nearby using. That it's, you know, I don't think it'll be the end of the world. So we'll see, though.
All right, moving right along to question number 4. This one's for Chris. What TX power are you using when designing a Wi-Fi net?
Well, it comes down to the design and what I'm designing too. So what are the devices you're actually implementing in the environment is really what kind of drives that power. You know, certainly the architecture of what you're implementing this wireless network in is going to play into that. as well as the devices and the performance of the, yeah, Joe Clark, max power, absolutely. No, so it really just is going to depend on what your transceivers are able to support, and what kind of performance you're trying to get out of them. So, you know, it really comes down to design, AP placement, channel or antenna type and placement, and then what you're trying to accomplish. So there isn't a standard power that I would recommend. It's all going to be dependent on what you're trying to accomplish. It's very, you have to look at what's being supported more or less in the environment, and then also determine if your budget's capable of supporting that type of design, and then make the proper recommendations on it from there. So the lower power you go, the more access points you're going to need, or higher gain antennas and whatnot. So really, really it all kind of plays into that. But yeah, it's all going to be dependent on the devices, and what, you know, what the overall design and budget's going to require for that.
Sweet. All right, chugging right along. We're getting quite a few questions in the Q&A panel, so I do want to make sure we can at least get to.
Oh, okay.
So question 5 for Jim: what is the best practice to provide Wi-Fi from one home to another nearby that is surrounded by many tall trees? This seems very specific.
Yeah, it does, but it's also, you know, you kind of, if I had a site layout or a picture, or knew how far, or, you know, many tall trees, like, is there a whole forest in between, or is it just, you know, a row of tall trees? The best thing to do is to dig a trench and bury fiber, or bury Ethernet, and then just forget about it for 20 years, because it will just work and you won't have to do anything else. Trust me, it's definitely worth the effort. If you have to do something wireless though, you know, use dedicated point-to-point stuff with directional antennas, and be very aware that, well, first of all, do it in the late spring, early summer. If these are deciduous trees, then the water content and the leaves are going to totally change the attenuation when you know, when the trees are full of life and leaves. So do that, and also be aware that as the trees grow, it's just the attenuation is going to get even worse over time. So it's only use 2.45 gigahertz. Anything above that's going to completely fall apart. And the other thing, maybe cut some trees down if you have to do wireless, and also if you do that, consider the whole Fresnel zone, not just the direct line of sight. So, but just bury a cable and forget it.
Yeah. Well, yeah, what's funny is I looked at that at the same way as, is it a point to point, or are you just trying to provide wireless at somebody else's house? So if you're doing that, you're not going to be able to just provide wireless in that area. That's not gonna work. And there's a couple of folks in the chat that are saying 900 megahertz for a point to point, because you'll be able to get through a little bit easier. So yeah, something non-Wi-Fi, you know, that you could use would not always be a bad idea, but it's going to, you know, really depend on, you know, what your budget is and what you're trying to accomplish. So in a point to point, super tall masts, get above the trees and know that they're going to continue growing year after year, and bury fiber. I think. Yeah. I think you're right. I think your mom had that before you got finished. You said fiber, and I just laughed and said, "Yep."
Don't be scared of it either. It's not that hard. You don't have to go very deep. If it's close enough, you could bury Cat6 cable even. So just a little bit of back-breaking labor one afternoon.
It's really just making me try to picture the scene that we're working with.
Yes.
Are these redwoods in California? All right. You can picture it for the rest of this webinar. Question number 6 from our dear friend Bruce. This is for Chris. Given a warehouse with varying levels of dense material inventory and Android-based scanners, what is your opinion on disabling data rates below 18 to try and control cell size to minimize channel overlap? Do you think 18 is too high?
Oh, so there's a couple parts of this that I kind of want to talk about, and Jim and I talked about this before, because we both kind of had the same ideas. If you're using if you're using data rates to manage your cell overlap, remember the RF is still traveling that distance. You're just putting out those data rates of what's being supported. So I would almost go back and re-look at the design and antennas and AP placements and use the power of the access points to really kind of control that, because changing data rates I don't think is going to buy you what you're expecting. But the other part is also with that 18 megabit data rate, can be troublesome depending on the devices that support it. So if you're thinking beyond the Android scanners, if they support 18 meg, that's great, but I would look more in the 1224 if that's what you're trying to accomplish. But also remember, your hand scanners are not really pushing that much data. So do you need to take it up that high to be able to support that level of data rate? I don't know. I think that's kind of where I would go with that. What are your thoughts on that, Jim?
Yeah, I'm old school. I remember the days when there were clients, and maybe they're still out there in some environments, clients that simply won't associate if 18 megabits per second is a mandatory data rate. The standard says only 6, 12, and 24 are required. So some clients are not going to do well with that. Now that's, maybe a little bit old school, maybe not as common, probably not going to hit that with an Android device. But I think, like you said, these tend to be low throughput devices, and using 12 will support a little bit more graceful roaming. And I'd look more into adjusting the design to the RF design to reduce CCI if that's the goal.
It's also good to support the supported data rate underneath the mandatory as well in your design.
Yeah, good point.
All right, moving ahead to question 7, which was already kind of a conversation we were having prior to the webinar starting, but let's get into it. So setting the stage here, assume the same SSID is enabled on both 5 and 6 gigahertz and clients received a RNR in a beacon or probe response. We've got 2 questions here. The first question is same SSID true in the RNR BSS parameters? And then question number 2, does the client compare the short SSID with the hashes of the SSIDs it knows? Let's get the chat rolling on question number 2, but let's talk about question 1 first.
Question 1 is yes. The answer is yes. That's what that same SSID bit is there for. So the clients know they can expect the same SSID in 6 gigahertz when they need to associate or probe there. Question 2, frankly, I don't know. I don't have enough experience with AP discovery in 6 gigahertz or real world experience with it yet to know what clients do with that short SSID. So we, talking before, we thought we'd ask the chat. Do you guys have any insight there about how clients are utilizing that field? So anybody out there that has a comment for Jan, let us know.
And for the first time, the chat has fallen silent. Well, if anyone just happens to spark,
it depends. It depends. Yeah.
When in doubt, it depends.
Oh, that's hilarious.
Hopefully, everybody's typing really long technical essays right now, and they'll just pop up in a minute or 2.
It's got to be it. Everyone is too busy Googling the answer.
Your man doesn't know. If he doesn't know, man.
Yeah. Well, that's food for thought. So as we learn and gain experience with 6 gigahertz, maybe we'll have to revisit this at some. All right. Speaking of your mind, it's time for his question. We've got question number 8 for Jim. So some years ago and still today, there's a problem where some clients do not associate or find WPA2 enterprise WLANs when fast roaming is enabled. They hide the IEs indicating FSR. Do you still see a lot of WLANs disabling FSR because of that, or do enterprises enable FSR and accept that those types of clients will not work properly?
Yeah, so I think there's a reference here to Cisco's adaptive fast transition. Is that what they call it, Chris?
Yeah,
Yeah.
adaptive.
I always mix that up with the other thing they came out with. And so we do have customers that use that. There definitely are still clients out there that won't associate to an SSID where fast transition is enabled. And so you have to do something about that. We see a lot of our customers, particularly in healthcare and manufacturing, disabling fast transition. Yes, because of those legacy clients. And not just legacy clients, brand new IoT clients that are just really shoddy and buggy, and you really have to coddle to get them to behave properly. Yep, that's one of the reasons why fast transition is disabled. I would say, though, there's another approach that works pretty well if you don't have adaptive fast transition available, or you want to make fast transition available to other clients that aren't Apple clients. And that is just a hybrid SSID with two AKMs. You have a .1x SSID that supports non-fast transition .1x as well as fast transition .1x. And in my experience, even in healthcare, most clients can handle that. They'll decide they'll pick that non fast transition AKM if they can't use it. And the older clients that can't use it at all or can't associate at all, they're less common, and maybe you can move them to a PSK network, to allow for more clients to overall to be able to use fast transition. So.
I think that's actually it for the questions that were submitted previously to the webinar beginning. So we're looking decent on time, which is good because we did have several come through. And then I saw Anders in the chat say something about a submitted question, Anders, but I didn't see your question come through. So if you want to put that in the Q&A panel, happy to answer it now. But let's talk through some of these submitted questions that have come through during the session. So Marcel, right at 11:08, bright and early, asked about a question about environment. Depending on the environment and AP density, the lower data rates are usually disabled in the 2, 4, and 5 gigahertz SSID. Is it needed or advised to also disable the low data rates of the 802.11n, AC, AX, CSs of an SSID, wholly abbreviations?
That's a good question. I don't think it's needed or advisable to do that. I'd like to hear what people in the chat think. I've actually never done that, even though some AP vendors allow you to do that. Clients can still use those MCS rates. I think the standard says they're all required anyway. So it can, clients may not like that. And also, they're only used for data frames, remember. So if a client is, struggling with connectivity, it's good to have those low MCS rates available that might be able to help maintain a connection and get data across. Actually wish they were even lower MCSs they could use, but that's a different story. So in my opinion, no, but
yeah, I would
open
not,
to other thoughts there.
No, don't disable the MCS rates.
Yeah.
Okay, I have a question that's for me from Craig about my gray goose lamp. So no one has asked, or I haven't heard about, where do I get a gray goose lamp? Is it new swag? No, it is Heather's personal swag. It's actually, I love to brag about it though, because it has lights in it and you can just have those on. But me and my dad actually make these. It's like a passion project of ours to make.
Oh, nice. You have a little Etsy shop where you can plug for people to.
I used to, it was called Liquor Lights and it was really cool, but I stopped doing it. It's just labor intensive. So now it's like a labor of love. So
Okay.
maybe if you're nice enough, I'll send you one. But, all right, moving back into our fun and technical questions here. So we've got one from David. Hello, David. Does AP installation in an outer part of a ceiling have real benefit comparing to an installation inside of the ceiling on top of tiles made from non-conductive materials? Height difference might be 10 centimeters. I'm wondering if the effect is measurable.
I would not recommend putting them above the ceiling tile. There's just,
Yeah.
even though it's above the tile, there's so much other stuff that's up there. You have ballast for lights and everything else that is directly in line with the APs. There's all kinds of other material that could be put up there. If someone moves, like, and the other part is trying to find the access points. So if you put them above a tile and they're not properly marked, and you can't put a sticker because that's going to fall off. So it's, one is locating them, two is the unknown of what else is up there. If you need to put them in the ceiling, they make ceiling tile enclosures that have covers on them that can store them properly with the proper radome on them so they can perform correctly. But unless it's a specific instance, like I've done work for hospitals that, in specific wards that they can't have access to anything, and we put them in those enclosures on purpose, that can be locked and stored and secured. I would recommend doing that rather than sticking them above the tile. There's just too many things that can go wrong in that scenario.
Yeah, I would also add, even if the tiles might not maybe non-conductive, but they're probably held up by a big metal grid that you don't want your APs up above. And I've had to laugh, Chris, when you mentioned just even being able to discover the APs, because I've had that experience professionally doing a site survey where an AP was up there beaconing for years and years, but had never been configured and nobody even knew it was there. And you go back and look at the site survey and say, what's that? I don't see that on my floor plans.
Yeah.
So,
So one of the other things I didn't even think about, we talked about this in design, is electrical codes and fire code. I don't know. I don't think I would check your local regs on that, but that's probably something else that would be into play. Now, Drummond says it would decrease multipath, but if you design where your AP placements are, you can take that into consideration as well. So,
multipath is usually not something we need to enhance when we're indoors. We usually get enough.
All right, got one from Andrew here with a wonderful pun. Are there certain devices that don't mesh well with mesh AP networks? Pun definitely intended.
I'll go quickly. No, not that I'm aware of. I think that, and he's talking about the consumer home mesh systems. From a client perspective, they're not aware at all that they're connecting to a mesh system. So, no, I'm not aware of anything that, I mean, if you have something that's hyper latency sensitive, then the application performance may not work as well, but in general, they seem to do okay in the home, at least when they're deployed properly.
All right, cool. And then we've got one last question that came through from an anonymous attendee, looking long into the future. And I already see 7 gigahertz, and I'd love to say long into the future, but we took a poll and people are already talking about it. So it's already in our minds. So looking long, maybe not so long into the future with the expansion of 5 into 6 gigahertz, we now have plenty of bandwidth to play with. That being said, is there room for growth into the 6 gigahertz band and beyond, or is the expansion blocked due to previous licensing? Jim's already shaking his head. Go for it.
Oh man, I have a lot of thoughts about this. Like if I'm going to be the ultimate pessimist, I think Wi-Fi will never get another drop of sub 6 gigahertz spectrum available to it. I think in the broad scheme of things, like there's very few users of spectrum that have, almost 2,000 megahertz of spectrum available to them. And I think actually, the 6 gigahertz band helps Wi-Fi kind of paper over some serious protocol inefficiencies just by throwing extra spectrum at it. I'm not going to go too far into that, but frequency reuse is not anywhere near what it could be in other, like we see cellular is capable of doing. So I think it's going to be a hard case to make that Wi-Fi doesn't have enough spectrum, and there's nothing else that can be done besides giving more unlicensed spectrum, opening that up so that it can keep getting better than versus, well, let's improve the protocol and make better use of the spectrum that we have. So of course, there are other things, 60 gigahertz and above, 802.11ay, really cool stuff going there. And maybe even in the terahertz range, a couple comments about Li-Fi there. But that really coveted spectrum, the mid-band spectrum, I think we need the protocol to make better use of it in the future. That's my take.
Well, what was the time frame between going from 5 gigahertz to 6? How long did that take to get that open? I forget the time.
Around 15 years.
Yeah. So I think, yeah.
Actually, sorry, I'm thinking of the DFS channels. Yeah, 5 gigahertz came. Wi-Fi built support for 5 gigahertz with 802.11a in 1999. So, but we really started using it, with 802.11n. 2008, 2010-ish. Yeah. So it's going to be some time before we even get any chance of getting more. I think we have to utilize what we got, especially with like you said, the amount of frequencies that we have available now. I think we have to fully utilize that before they start looking at more. It's a hard road too, because where would we get more unlicensed spectrum? Well, maybe the cellular operators, the FCC, would reallocate some of their spectrum. And they make a very compelling case that, look at the spectral utilization of our spectrum, the cellular spectrum, and it's very high. And then look at the unlicensed bands, and it's comparatively much lower. And they say, no, they need to make better use of that spectrum. So it's a little bit unfair because they don't have to share the spectrum with anybody else. So there's no listen before talk or being polite or being very careful about avoiding each other, which is part of that inefficiency in the unlicensed band. But yeah.
Awesome. Well, that is all of our questions, crushed on time. Big thanks to the panel, my friends Jim and Chris, for leading the charge here. Thanks to all of you for joining us. That is a wrap on this expert panel QA session. We're actually going to do these like every 6 weeks because they're so fun. They're so interactive. We like them. You like them. So let's just keep doing them. So keep an eye out for that in the next 6 weeks. But we will be back here again, same time, same place every week, Wednesday, 11 a.m. Eastern. So we will see you next time. Have a great rest of your week, everyone. Bye-bye.
Thanks, everybody.
See you.